Yeah, rice spins it. So that's why you put rice in the salt shaker. And my daughter used to say, my daughter used to be confused by that because she never asked why it was. She just formulated a hypothesis. She would say, the reason, what happens is if you leave rice in salt in the salt shaker too long, it turns into rice. So that's what she came up with. But anyway, what we're looking at here is we're looking at some lock and hub stuff. This is some driveline thing here. And so the Bronco that we got out there has got lock and hubs like that on there. And basically what you got to do is you got to have to take your drive line and connect it to the hub, because you don't really want to be driving those all the time. Now a lot of your later model trucks, your Chevrolet trucks and stuff that we got now have got CV axle, CV joints out there, and the locking is done in there a little ways. You know, they got a collar that slides over and locks them. That's vacuum operated or whatever, and that's, you know, Jeep used to do that. You remember the old Jeep, Army Jeeps, like you drove in Vietnam? They did not have locking hubs, right? They actually had a lock that took place for the axle to lock. If you got them running all the time, you're doing a lot of wearing out. But anyway, you got a locking knob, like you see on there. You got to engage your front wheels. Now that's really sort of dangerous, because I have known people getting out to lock the hubs, and then the thing would slide in the mud and fall over on them. You know, and that happens sometimes. And so the inner ring is splined to the hub over the axle shaft sleeve ring. So basically you're splining all that stuff together. The pressure on the first spring is released when you turn it to the free position. And there's just basically looking at your picture of the way it is. This is a public domain stuff I got from Ford, so, you know, go for it. All right, now right here, let's go down, let's go a page down. All right, let me see. Now this right here is your automatic locking hub assembly. And basically that's what happens right there. You know, whenever you put it in four-wheel drive, it spins up and locks automatically. You know, and there's all the little pieces and parts that goes with that. See, there's a lot of them. If you look, you got a neat little list of these parts down here. You know, your hub, your mainspring, your cage, your clutch spring. Now, the reason this is handy information, when you got an exploded view like this, you know, like anything that you're working on that's mechanical like that, you're going to need to be able to, if you say, okay, I need this part right here, and then you look down here and you say 10, which I didn't scroll down far enough for you to see 10. You know, 10 is actually going to be the inner drive gear. So if you go in there with your picture and you tell your parts guy the inner drive gear is the parts you need, he knows exactly what he needs to get for you, you know. In some applications, this stuff will come as a sort of a kit. Okay, so and since some hubs are locked by vacuum. Okay, so on the automatic hubs, now, how many of you guys, you've driven these Fords with automatic locking hubs, when you put it in four-wheel drive and it locks in the hub, when you get through using your four-wheel drive and you put it back, you know, in two-wheel drive, you're supposed to back up the length of the vehicle to let these hubs unlock. If you don't do that, you're still driving along, whirling all of your, you know, stuff that they're wearing things out you don't need to wear out, you know, and it all hurts your mileage and all that too. Okay, now there's your vacuum hub components right there. See that? Yeah, see how that works out right there? They got O-rings and stuff in there where they'll trap the vacuum and all that, because it's vacuum operated. And if you look and see how that operates there, you see how it works? This body snaps over the end of the hub and it creates the outboard into the vacuum cavity. There's your hub lock body. There's your vacuum cavity there. The hub lock body seals to the hub with an O-ring, provides a piloted bearing journal for the drive gear, going to support the half shaft, carries the vacuum diaphragm that actuates it. So it's actually actuated by vacuum instead of having all these mechanical springs and all that stuff. Look at your first question. What does it say? In a vacuum locking hub, the hub lock body seals the hub with an O-ring, provides vacuum diaphragm that will activate the hub lock piston. Does that look like the right answer for that? This is what do you think? Who said false? Who said true? He said false. All right, what's wrong with that?
The hood lock body with an O-ring
creates the outboard end of the vacuum cavity. Yeah, basically.
You didn't say bearing in there.
Yeah. So basically, that's going to be a false one there. The way the question is worded. All right, number 2, in a vacuum locking hub, it takes 11 inches vacuum or greater to disengage the piston. We haven't really got there yet, have we? All right. What do you see there? All right, the drive group collects the half shaft. See out, that's right there whenever you're locking in there. The disengaged spring keeps the clutch ring in the idle position unless it's opposed by the engaged spring within the piston assembly. All right, what do we say here? Oh, here we go. Look at that. The piston assembly engages and disengages the hub lock by controlling the spring. The full stroke of the piston unlatches the piston, releases the spring.
False.
There you go. 11 inches greater to engage, 5.75 to 7.1 inches to disengage. That's what we're looking at there. All right, yeah, this is a short handout, by the way. All right. Let me hit you with this right here. An automatic locking hub will remain in the lock position as long as the wheel continues to turn in the same direction. Now, that's not talking about the vacuum ones. That's talking about, that's what I was just telling you a minute ago.
True.
Right, it is true. The disengaged spring keeps the clutch ring in the idle position when opposed by the engaged spring within the piston assembly. That's false. All right, now then, number 6, when the vehicle is shifted into all-wheel drive.
This one, he did. He missed 3 good.
Missed 3?
Yeah.
And on vehicles with automatic hubs, the rear axle shaft rotation locks the hub. Rear axle shaft? I don't think so. We're talking about front, right? So that's going to be, all right. But the axle with the front axle shaft is actually what locks the hub. All right, you got that?
That was false, right?
Huh?
Yeah.
Yeah. Okay, number 6, when the vehicle shifted into four-wheel drive and axle shaft rotation occurs, what is actuated? What is it that's actuated there? That's going to be C there. It's going to be a cam. There's a cam in there that rolls in. You know, cams do a lot of things on these cars here. And then number 7, to unlock the hubs after the driveline lineup has occurred, what do you got to do there?
Drive in the opposite direction, if you will.
Yeah. Yeah, back up in several feet. But actually, it's going to be, yeah, that's right. You're correct. It's not, D is usually all of the above, but in that one, D is the one that he just read.
You do that with all four-wheel drives?
No, just on certain ones. No, you're not on all of them. The piston assembly engages and disengages the hub lock by what? The outboard end of the vacuum cavity. Controlling the piston string, and then the outboard end of the vacuum cavity is is created when the hub lock body snaps over the end of the hub.
So the
Got our words all crossed up here. Yeah.
So what's the?
So number 8, on number 8 you're going to write down controlling the piston spring, and on number 9 you're going to create the outboard end of the vacuum cavity. The inner spring is compressed as long as the hub is locked. That's not. That's a very short and sweet little 10-page handout. It just talks about locking hubs and again familiarizes you with them and the basics.
What's that?
Inner spring is what?
The inner spring, that's the number 10.
Yeah.
I don't know what number 9 is.
Number 9 was the outboard end of the vacuum cavity. That's what that is. Alrighty then. Alright, now let me get into this one here. Alright, this one right here. Now then, we got some four-wheel drive stuff here. This is going to be Powertrain Fundamentals Test 11. Okay, what is that we're seeing on the screen there? What are we seeing? Are we
We
seeing?
were looking at a differential.
No.
Differential transfer case.
Transfer case. And what is this item over here on the right?
That's some kind of electrical module.
That's called a generic electronic module. The reason they call that is they can take the circuits in that module when they originally designed it and make them do all kinds of things. And the four-wheel drive was controlled on a lot of the trucks by that. Now you've got the thing that sort of replaced the generic electronic module on the newer ones is called a smart junction box. It's basically a fuse panel, got a computer in it, and it's got some internal relays and all.
It's like the new Silverado, well,
You said 11.
Ford Silverado,
You meant 10.
four-wheel drive, they have that.
Yeah, a lot of them have got, huh?
You said 11, but you meant 10.
Powertrain, well, the one that's, is your first question if the 4x4 symptom has set a diagnostic trouble code? Is that the wrong one?
No, we got the vacuum control cylinders that are controlled by the PCM, true or false.
Oh, no. Okay, well, I got to fix you guys up with a different test right quick. I'll pick up. Yeah, we got it hooked up here. Let's go. This is another short 10-question test here. Vacuum control solenoids are controlled by the PCM was the first question.
True.
Well, are they? Really?
No, they're not. It's vacuum control.
Huh? Let's look at,
No, they're not.
all right, you see this?
No.
Look at your inputs and outputs on your GEM. Okay, somebody tell me what that top left one is there.
like some stuff was
All right, I got a, number 3.
The screw hole.
I got number 2 is what? What's number 2? Anybody recognize number 2? What is this one right here?
It looks like some little
Have you seen this before?
Yeah.
It looks similar to like a blend door, actually.
Sort of, yeah, it does, but think about, we're thinking transmission and so.
Yeah, so it'd be like a
Differential
air
cover
shut
or
off,
something.
vacuum shut off.
No, what about your, neutral safety switch, or your transmission range sensor, if you wanna call it that? That's what that is.
Okay.
That's basically that. Now, why does it need to know what range the transmission is in?
So they can do, yeah, well, I mean.
Who has a 4-wheel drive? Okay, you don't go into 4-wheel low unless you're in neutral when you put it in there, do you? You don't shift on the fly into 4-wheel low, because that causes things. Sean was telling me that he had to go up you might have seen it on my technical rider page. He went up to, had to go up there and retrieve this Ford pickup truck that was driving down the road, and something went wrong with the, I think there was a recall on that. Something went wrong with the gym module, and it put it in 4-wheel drive, or 4-wheel low going down the road.
I was driving with a buddy, mine was doing about 60 going down the road, and his girlfriend kicked his on the 4 low going 69.
Yeah.
It shattered the transfer.
Yeah, it just destroys it. It blows up like a bomb.
I think the biggest piece was found like that big.
That's scary too, I bet. All right, but anyway, what's this piece right here? What's this right here? You guys really are. This right here is this right here it is in the real
Like a hay
world.
barn.
What is that?
For the box.
I hear you on the box.
There's a difference in size.
I agree.
See?
Oh. What do you do?
Throttle position sensor.
Oh.
You guys? Okay.
Yeah.
We need to do some advanced training in here so people will understand what they are. Now, if you look at these 2 pieces right here, what do you see there?
Like a permanent magnet sensor.
Yeah, these are sensors here, obviously, there's sensors here. We're gonna look at the little legend in a minute and see how many we got right. What about that? What is that? That is a strange looking thing, isn't it? Now, if you've done any work much on, the older Ford cars, you'll recognize that's a stoplight switch for an older Ford car. And then that right there,
Spark plug.
what's this right here?
Then
Vehicle speed sensor. Okay.
and like when you stick in the.
That one right there, what's this? That's the knob that puts it in 4-wheel low and all that. All right. Now over there we got some stuff too. I see. What's number 12 up there? I see some vacuum lines. I see some wires. I see some solenoids. Right? Okay. Now what item is this?
The GM.
GEM. So if the GEM has actually got arrows pointing to that, what did it tell you about that question that you just said was true? The PCM controls the vacuum solenoids. What do you see in here? The GEM controls the vacuum solenoid. Got it? And then that's another little controller there. What is that controller? I'm confused. I don't know what that is. And this one right here, you recognize that? I'd say that's probably the transfer case shift motor. You know, the one that hangs on the transfer case that makes the shift. And how many of those we get right?
No.
This is actually, these are inputs. Look at how this is done. You got an engine controller, not a GEM motor, GEM module, not an engine controller. And it actually is taking input from all these things to decide what to do with these things. Now what the Sam Hill is this darn thing? I don't know what that is.
The filter.
It ain't no filter. Please. Make it up as you go. Alright, let's look and see what number 13 was. Torque on demand relay. Ooh, that's cool, isn't it? You got that? Shift motor, sense plate. That's part of all of it. See, that's basically, they're saying that because it's they're pointing a black arrow at the shift motor sense plate. That's what that deal is there. Alright, now let's look down here. Digital transmission range sensor. That was number 2. That's what we were talking about. Alright, now we got front output shaft speed sensor, throttle position sensor, rear output shaft speed sensor, brake pedal position switch. They used to call that the boo switch, brake on off switch, but now they call it the BPP switch. It was easier to say boo than it is to say BPP. I don't know why they did that. They love them acronyms though. 4-wheel drive mode switch, clutch pedal position sensor. That's number 8, clutch pedal position sensor. That one. That does not. You'd think that was an injector or something almost. And then all of this stuff: GEM module, vacuum shift solenoids, torque on demand, automatic 4-wheel drive indicator light, and all that.
Garrett thought it was a spark plug.
Yeah. Oh, please. Again. All right. VSS stands for vehicle speed sensor. Hmm?
Wicked Navigator.
Is that what that stands for?
What, no.
Yep.
What you got?
Oh, we're doing that, I never talking about mine.
All right, you see that? Number 9.
I didn't know what NMA stands for.
VSS, I'd say that's probably true. Wouldn't you say that was true? Doesn't VSS stand for vehicle speed sensor? I think that sounds right. The clutch coil magnetically pulls the armature against the cam coil housing assembly. All right, now right here, got your electric shift motor. Let's talk about that for a minute. On some vehicles, it drives a rotary cam that moves one shift fork to select between the lower high range selection. Now, when you guys get over to tear the transfer case apart, there's a sheet I give you guys. You take the transfer case apart, look at how it's put together in there, and put it back together so it'll work right. This is not as complicated as taking a transmission apart. There's not as many parts. It's not as big of a deal. But a lot of you probably don't know that a transfer case has got an oil pump in it. You know that? So if you've taken one of those apart, they got an oil pump truck for me. Most of them. I know about it. On other vehicles, electric shift motor drives a rotary cam that moves 2 shift forks electrically in 2 high, 4 automatic 4-wheel high, low range selections. Okay, shift motor sense plate. Think of the shift motor as a really elaborate windshield wiper motor. You know how the windshield wiper motor's got the little park switch inside of it so that it'll always park? Well, the GM needs to know where that is. A lot of times if you've got one, they say, hey, when I tell it to go in 4-wheel drive, it won't go in 4-wheel drive. I like to take the transfer case shift motor off the transfer case and plug it in and push those buttons and see if it, put it in neutral, switch on your key, and push the buttons and see if that little actuator will turn back and forth. Because it's basically got little inputs coming out of it to tell the GM module where it is, so it'll know where to put it. If that's the case, then you take your little screwdriver or something and stick up in the actuator and see if you can move that thing with your screwdriver. If it's bound up or something, you gotta go into the transfer case. But usually, you don't have a bad shift motor. What I tell you guys about what usually fails?
Whatever working the hardest.
The thing is, in the most hostile environment, is doing the hardest work is usually what's going to fail. That's usually that's my rule of thumb. I've never heard anybody else teach it that way, but that's what I've always experienced working in the field. And that's what I think about. If it's working hard, if it's spinning in hot water, and if it's got a lot of heat and vibration and oil and trash and all that going around it.
So number 1, when it says the vacuum control cylinder is controlled by the PCM.
That's the GM. That's going to be a falsie.
And
The shift, let's go down here and talk a little bit more about that. Okay, let's drop here. 4x4 shift motor relay. It's got 2 solid state relays. The module with 2 relays built into it is controlled by the GM, and it controls power to the shift motor between different transfer case models. See that thing up there? There's what that relay looks like. If you were familiar with some of that stuff, you might even think that looked like a wiper governor or something, but that's not,
So
basically.
what is an ISO relay?
An ISO relay is one like what we got on the wall, the one behind you right there. See it up there? That's an ISO relay. International Standards Organization. They've been using those things for years. Volkswagen was using relays like that in the early 60s. They've been around forever.
So the shift motor is not one of them.
No, it's actually got, all right, it's not a standard ISO relay. And then the 4x4 low indicator lights and output of the GM module is illuminated when the transfer case is in 4-wheel drive low position. Okay, what else has to happen when you're in 4-wheel drive low if things are going to work right? Your transmission is a different shift schedule, doesn't it? Based on vehicle speed.
Yeah.
You got it. It's going to have to shift. Did you guys remember me telling you that story about that guy that had a 4-wheel drive pickup truck that he rebuilt the transmission in because it was shifting into its highest gear at 20 miles an hour or something like that, and the problem that he had, the reason it was doing that, and it was on like a 96 model Ford pickup, was that it was, the fuse was blown feeding some of the indicator lights in the instrument cluster. And because of the fact that the PCM wasn't seeing the 12 volts, it should be coming through that 4-wheel. See, if that 4-wheel low bulb is not illuminated, then it's going to see the 12 volts coming through the bulb to the PCM, and it's going to think it's not in 4-wheel low. But if it goes into 4-wheel low, the little switch closes the ground of that bulb, and then the VCM doesn't see 12 volts, and it goes into that other shift strategy. And on that particular one, all I had to do was go over there and show him that the fuse was blown. We put a fuse in there, and he had all those shifts right again. So he had gone a long way around Robin Hood's barn without even switching it on to see if his 4x4 low light was working. You had to think kind of outside the box on that. All right.
Just watch that series.
The front and rear output shaft speed sensors magnetically sense tone wheels in the front and output shaft and rear output shaft, and their signals are sent to the GM you know, or if you've got a smart junction box and it's set up similar to this, front and rear output shaft speeds. In automatic four-wheel drive, the GEM senses the difference between the output shaft speeds. The clutch coil duty cycle is increased until output shafts are turning at the same speed. Now, when you hear about a clutch coil, think about, you know, you guys this semester have all seen air conditioner compressor clutches with this little coil on the front. That's what's in the transfer case. It's something very similar to an air conditioner compressor clutch. And basically, as you send a duty cycle to it, it causes everything to start spinning the same speed as it electrically clicks in, and it gives you your, you know, on the fly stuff. And it's got to shift on the fly if it's automatic, doesn't it? If you had automatic four-wheel drive, you wouldn't have expected to put it on the screen and say, "Oh, stop," so I can put it in four-wheel drive. It's going to have to do that automatically, right? Okay, there's your clutch coil. Now you got a question about that in your test right here. Look at it. It's GEM control through the torque on-demand relay. It magnetically pulls the armature against the cam coil housing. It's located inside the transfer case on the rear cover, and it's power side switched. Now, what are we talking about when we say power side switched? What does that mean? What's power side switch talking about?
It flashes power on and off.
Instead of ground. In other words, a lot of stuff is hardwired to power, and it'll be controlled by a ground. This one here is hardwired to ground, and the power is turned on to it. That's how that works. The GEM controls the clutch coil through the torque on demand relay, and when the GEM activates that solid state relay, battery voltage is supplied to the clutch coil. There you go. Just like that. See, and you notice one thing distinctive about that torque on demand relay, they drew it with cooling fins on it and stuff. When it's working hard enough to where it needs to cool off, you know it's got some heavy duty stuff going on in there. And there's that coil, that clutch coil that they're pointing out in there. Okay, now you got your digital transmission range sensor. See, we don't like a whole lot here, guys. Watch this. Digital transmission range sensor sends a signal to the GEM for a transmission shift position, uses the signal to determine when the transmission is in neutral so that you can shift it out of the four-wheel drive load position. So in and out, it needs to be in neutral both ways. Remember what I told you about the little S10 Blazers and all that stuff? They won't, the neutral, transmission range sensor / neutral safety switch / backup light switch, it does all that stuff. If you've got that thing anywhere except park or neutral, the hatch won't work, the electric hatch, because you don't want to be driving down the road and accidentally bump that thing. Somebody other lose your kids, your dog, your ice chest, and all this kind of stuff because the hatch opened up while you were driving down the road. So they got it where, think about this, if you're saying, well, somebody said my hatch don't work. We had one that the guy pull the transmission out, just, put a rear main seal in it, the engine or whatever, or a torque converter clutch seal in it, puts it back in. The guy comes back and he says, my electric hatch release don't work anymore. Well, the guy didn't quite plug that thing back in good enough. Well, see, basically, if anytime your engine controller needs to know whether you're in neutral or drive, it's going to look at that thing right there. Now, there's another thing, it's an interesting way that they chose to do it on some of these earlier pickup trucks. It would look at the wire going from the starter to the starter solenoid, which is out there on the fender on some of these things. Okay, what are you going to see in that wire whenever everything's at rest? It's actually going out there. It's supposed to send power out there. It's supposed to shoot power. It's a power side switch because you turn your key to start. It's going. No. Okay, so if I'm not on start position, what's going to be present on that wire going to that starter solenoid? A ground. You're going to see a ground that's going to be coming through that coil, right, on the relay. Okay, so you've got that. So if the engine controller can look at the other wire, see, when you turn your key to the start position, that power is going to go from the ignition switch down to this neutral safety switch, or this transmission range sensor, or whatever you want to call it, and it's going to go through there to the starter. If I've got this thing anywhere besides neutral or park, it's not going to start, is it?
No.
All right, so I'm going to measure a ground on the wire that comes from the ignition switch. And if I don't see a ground on that wire, what does that mean? I'm talking about upstream between the ignition switch and the transmission range sensor. I'm tied into that wire, and my engine controller is watching that wire. Now, if I see a ground on that wire, what do I know? I know I'm in park or neutral. Yeah. If I see anything but a ground there, it's not looking for power. It's going to see if there's a ground there or not. If I see anything but park or neutral there, then it knows that you're in drive or reverse or somewhere else besides park or neutral. See, that's one way they used to look at that. And this right here, a lot of the time you'll be surprised how they'll do that now, because that's the simplest way to do it. And the way that I always figure this kind of stuff out, I always think about if I was an engineer and I had to design this so that I could draw a signal, what would I hook up to? And if you think the right way, you can figure out why they did this, And a lot of times when you start to understand how things work and why they work that way, you can figure out other cars because everybody's pretty much got to do the same job, don't they? All right, so. All right, now then, we don't like a whole lot. We got just enough to cause Daniel Kelly to turn into a skeleton. All right, now then, let's see. All right here, the throttle position sensor is sent to the jump by the power strength control module. That's that little thing right there. Uses it to increase the clutch coil duty cycle under heavy throttle or off throttle conditions with a vehicle speed above 30 miles per hour. You got that? Using GM A4WD, automatic four-wheel drive GM strategy on some vehicles, except vehicles is misspelled and it's got 2 S's on it. You got that? All right. Okay. Let's look at this next question here just for the heck of it, number 6. Which of the following is not an input to the GEM related to electronic 4x4? Got any idea? Think about it. I got a digital transmission range sensor, I got a torque on demand relay, I got a throttle position sensor, I got a clutch pedal position sensor. Is that a trick question?
No.
What did you say? Which one did you just say? Okay, I need somebody in here that's smart enough to figure that out. What about you, Danny boy? You got that? Read the question carefully.
Which of the following is not an input to the GM related?
Which of the following is not an
The
input?
torque on demand relay.
Why is that?
Because it receives.
It's an output. Bingo. Do you see that guy figure that out? That's what I was trying to get. I'm trying to get you guys to where you can think. We have to strengthen those neural pathways, okay? All right, now let's look at number 7, the torque on demand relay. What?
D.
You got that right, buddy. Listen to him. He's on a roll. All right, let's look at this one here. What's this right here? What's the CPP switch? Clutch pedal position switch. Input to the GEM allows engagement or disengagement of the four-wheel drive low position. It's located on a clutch pedal bracket. Okay, and so I wonder on that one there, like if you're using a clutch pedal position switch to make, why is it connected to your cruise control? Why would your cruise control give a rip about your clutch pedal? If I've got this thing on cruise control and I'm driving down the road and I've got it set on 58 miles an hour or whatever, and I max the clutch, do I want the engine to go, no, I want it to drop the cruise when you max it like that. But I mean, there's all kinds of stuff that it's going to look at the clutch pedal position switch for. And what they also do, and a lot of people don't think about this, a lot of the times on your clutch pedal position switches, they'll actually have the clutch pedal position switch, you know, with the cruise control and the modules that watch the brake pedal position are basically looking to get you remember what I was talking about, the ground coming through that solenoid? They'll watch for that ground coming through the stoplight bulbs. And whenever you power up the stoplight bulbs, that ground goes away. It's not looking for power, it just looks for that ground to go away. On the clutch pedal position switch, if you wire it up in series so that it's looking at that ground and you mash the clutch and that ground drops out, see, it knows you mashed the clutch. But either one of those, the clutch or the brake, can drop that ground because of the nature of things. Anyway, the clutch pedal bracket. Let's go to this next part. BPP switch. Input to the GEM allows engagement or disengagement of the four-wheel drive low positions located on the pedal bracket. That's not complicated. There it is right there. All right. Now then. Now look at your vehicle speed input. There's 3 different ways it can work. And that may be a question down there on that, I think. Hardwired from a sensor. It can be hardwired from another module. And it can be read from the multiplex network. So if I'm going to get vehicle speed from the multiplex network, where is it probably coming from?
If you can, what, say again?
If I'm going to get my vehicle speed information from the multiplex network, what am I probably reading? Where does it originate, you think? What about vehicle speed sensors? I mean, not vehicle, but wheel speed sensors. Wheel speed. But anti-lock brakes are going to read wheel speed sensors. And I say, well, we know how fast the car is going anyway. Why don't we just send that information over here to this booth? Because he needs to know it too. Now, some of them, they would have the sensor in the rear end come to the anti-lock brake control unit. And then that would align it and define it and send it to the PCM, send it to the send it to the engine controller, the instrument cluster. So the instrument cluster and the PCM would get their vehicle speed information from the anti-lock brake unit, which was reading the, you know, that's what that's talking about right there. So, you know, if you're thinking about that, you say, well, we got some, like, you know, people that are working on stuff here, well, let's make this talk to that. So the long and short of it is, if you're trying to figure something out, you need to know how this thing's wired, where it's getting its signal from, and all that. And that's one of the reasons that you need to know how to read a wiring schematic and look at go to your description and operation page. You'll find a paragraph a lot of times that'll tell you how this stuff is wired up, so you're not scratching your head and having to go find somebody to fix it for you. It's like I was saying yesterday, within a couple of 3 days, if you're working somewhere in a high intensity environment, they're going to know if you know anything or not. And if you have to go ask for help about 3 or 4 times in a row, they're going to say, oh crap, why do we even hire this guy? We're going to be holding his hand all the time. All right, right here. Now, oh, look at here. That's pretty good stuff right there. What do you think? All right, you see that? Fused junction panel. Right? All right, and this basically feeding what? The gym is also feeding that solenoid. It's also feeding that solenoid. All right, and this right here, the gym module is actually going to be controlling those 2 solenoids with what? Are these solenoids ground side switched or power side switched? Daniel Kelly, are they ground side switched or power side switched? You came up with the right answer a while ago. He's about trying to do a skeleton over. Look at him. Go ahead. Huh? Power side switched, are they? Are they hardwired?
That switch-
They look to me like they're hardwired to power.
That swivel is power, right?
Yeah. No, I mean, if they're hardwired to power, the other side got to be ground. Those are ground side switches, right? Okay, now you got vacuum. This is a cool little diagram right here. But you got vacuum feeding, say number 7 is your vacuum reservoir. It's fed by the engine, yeah. And then number 8 is basically going to be a little check valve there. That check valve, vacuum comes in from there, it gets trapped here, so that you've always got vacuum, even if the engine's not running, or even if you're in deep in the throttle. Okay, and this vacuum is actually, when the GM tells that to turn on, it's going to send vacuum over here. And it basically can drive that one way or another. And what's this connected to? Yeah, vacuum shift motor. It's basically going to put it in and out of this. That's what locks your hubs.
So the vacuum reservoir is just a fail-safe just in case solenoids don't work?
Yeah, the vacuum, what's
So
that
you have
now?
enough-
No, actually, that's on a different system. I mean, that's basically what's going on the ones, the later model ones, that puts it in, that locks the hubs in. Sort of, they're actually, the hubs are locked in all the time, but it locks the axle to the, you know, the coming out of the front end, the front differential, into the hubs going out there on the later model vehicles. Vacuum shift motor moves a manual lever that engages and disengages a shift collar inside the axle assembly. I've actually got one of those over on a bench I need to show you guys so you'll understand what you're thinking about there. Imagine a shaft, 2 shafts that are right next to one another, and these 2 shafts are not connected at all. They're actually riding in a, you know, so that they're always real close to one another. And on one of them, there's a little shift collar that can spline, you know, slide over so that it connects those 2 together. That's what that shift motor is moving. It's got a little fork in there. And that's, so they basically can, when it locks in like that, it's like those 2 shafts are one. All right, now let's look at here. Vacuum control solenoids do what? That's number 8. The shift collar, and the shift collar is, like I say, back there on that table by the grinder is actually a little piece of a front wheel, 4-wheel drive front axle. It's got a shift collar that I can show you guys whenever we get out there into the shop. If I was a decent sort of a person, I would walk out there, get it, bring it back in here, and wave it in front of the camera. But I'm not decent today. Okay, number 8. The vacuum control solenoids, we already got that. What purpose does the digital transmission range sensor have in an electronic 4x4 system?
When it is in the neutral position.
Yeah, he wants that having number 10. The electric shift motor does what?
Drives a rotary cam that moves off.
He did good.
Shift fork to the electric and the lower high range.
And he's got his radio voice over there and all that. Alrighty then, well, what do you think, guys?
I'm gonna write that down.
I think we need to